This is a diagram of the Midmark or Ritter M7. And basically what you're looking at is we have a separate reservoir for our water. We have a single valve that allows the flow of water into the chamber and steam back out of the chamber. We have a way for the air and any light steam to be taken off the top of the chamber. That gets past a temperature gauge so we know that the machine has reached its operating temperature. And we have the bellows we were just talking about earlier that allows that steam within the chamber to circulate properly, and it allows us to get that cold air and light steam off of the top of the chamber. That material is dumped back into the reservoir where it condenses and into water, which we can reuse. So we're not having to put water in this on every single cycle. Also, when the steam is released back into the reservoir, it goes through something called a condensing coil. This is an open-ended copper coil that allows the steam to condense back into water for reuse. So this is basically the simplest version of a sterilizer. Now we're going to take a step up into a slightly more complicated version. This is the valve assembly to a Pelton & Crane OCM or OCR. It's a unique device. It actually has flowing water through it, flowing steam through it, and 120 volts AC, all within the same device. It's pretty amazing that it can keep AC separated from all that water, but it allows us to move the steam more efficiently into and out of the chamber. Again, it is actually manually driven by a camshaft pressing on two rods that either let water into the chamber or steam out of the chamber, but it still requires the intervention of a technician. Moving right along, we're talking about the differences between, the similarities between automatic sterilizers and the manual machines we were just talking about. They all use water. They all have specific cycles. They use some valves. We have output devices and timers. Every one of these devices, every one of these machines has a safety device. We have to have a way to seal the doors, so we have a door gasket, valves, and various filters. When we step away from a manual machine to an automatic machine, we're taking the responsibility of moving the cycle forward away from the technicians so that they can set the machine and not have to worry about coming back to the machine. When they come back to the machine, the machine will be finished. I believe we had some questions. Is there any questions up until this point? Let's try to get a few more in if there are any.
Hi, Neil. We do have one. How often do we have to perform preventive maintenance on the sterilizer? Is it 12 months, 6 months, or 3 months?
We recommend 12 months preventative maintenance on these machines, but there are also things that should be done by the operator on a daily, a weekly, and a monthly basis. On a daily basis, you need to make sure that the water is kept clean and changed out. We don't want any bioburden buildup within our reservoir or within inside the chamber of the machine. On a weekly level, your technicians should be cleaning the machine to make sure that we don't build up any residue from cleaning products used on the instruments or from the instruments themselves or the wrappings that are used. And then on a monthly basis, you should be checking your safety relief valve to be sure that there are that it's functioning properly and that it reseals after each use. Okay, let's move on.
Okay, the next question is it okay to interchange steam trap with bellows type valves?
It is okay. They both function under the exactly the same way. The only difference is in the technology, and we have not found that any disadvantages to one way or the other instead of a steam trap over a bellows. The intent was that the steam trap, because it contains less flexing devices, would last longer, and there is some anecdotal evidence to say that it does, but it is just as likely to be become damaged by dirt or material getting into the sealing surfaces. So depending upon the cleanliness of the machine, the steam trap may not last any longer than the bellows.
Okay, one final question for now. Do tabletops require state permits similar to larger sterilizers due to being a pressure vessel? If not, then why?
The permitting system is different for tabletop sterilizers as opposed to bulk sterilizers because of where they're being used and the regulatory agencies that are overview the usage of these products. All sterilizers that are produced for sale in the United States are ASME certified. That means that the materials that went into building the sterilizer were certified as appropriate, and that the various safety devices are set up so that the operator is protected. And in many cases, such as a small clinic or a dental office that are not covered by things like JACO, that's appropriate for that situation. Now, there are several states that are looking actually into increasing the certification for such things as small clinics, dental offices, and any place that a sterilizer would be used in a spa or a beauty parlor, but that's on a state-by-state basis, and that would be your state regulators that should be involved with that. Any other questions?
We'll go ahead and proceed with the presentation at this point.
Okay,
if we don't get to, for the attendees, if we don't get to your question at this time, RPI will follow up with all answers at the conclusion of the presentation.
Very good. So now we're back to talking about the differences between automatic and manual sterilizers. Automatic sterilizers give us an opportunity for self-contained diagnostics, troubleshooting cycles, and we get codes that can be outputted to tell us what has happened during the cycle. We get an opportunity to hook up a printer that tells us on a moment-by-moment basis exactly what the sterilizer believed happened, and can be used as record keeping so that you can have a permanent record that the instruments did complete a cycle. We do have automatic sterilizers that monitor not only the internal temperature of the chamber, but the external temperature of the chamber, so that we can be absolutely sure that the environment of the heating elements is operating properly, and that we're reaching the temperatures that we expect to reach. We have timing circuits that allow the flow of fluid through electronic valves. We have dams and water gaskets that allow us to control the flow of fluid within the sterilizer. This is basically what an automatic sterilizer's microprocessor has to be able to integrate. We have information from sensors, temperature probes, pressure sensors, water level sensors, overheat sensors, and what the user actually has asked the machine to do, the cycle inputs. Outputs, we have an opportunity to tell the operator that there's a problem. We have information displays, we can control valves, and we can output to a printer. Moving right along, on the automated sterilizers, instead of having a mechanical valve that someone has to actually move forward, we have an electronically controlled valve. This is the valve to the Midmark M9, M11, the newer style machines. It contains a valve for filling the chamber and a valve for venting the steam out of the chamber. It is AC driven by a coil that pulls a piston off of a seat and allows the flow of fluid into or out of the valve.